Hello, welcome back. In this video, we are going to learn about media access control or the MAC layer. So what is the agenda? I will be introducing you to the media access control or the MAC layer, then random access techniques, after that ALOHA, then CSMA, after that CSMA CD, followed by CSMA CA. Let me introduce you to MAC layer functionalities. Earlier, we have learnt about the data link layer, where we have seen that the functionality is to make a reliable connection between the two nodes. That means node to node communication. Here we have assumed that the link between the two nodes is available. Now in this MAC layer, how the link will be utilized between the two stations operating will be discussed here. If it is a point-to-point link, that means there is only one link between two stations A and B, then we have a dedicated link and hence no sharing is required. But in actual reality, we have multi-point connection where large number of devices can communicate with one another, and as such a link must be shared. So how this sharing will be done is introduced in the media access control or the MAC layer. Now for multiple access protocols, we have three different types of protocols. One is the random access protocols, second is the control access protocols, third is the channelization protocols. In random access protocol, we have the protocols such as ALOHA, CSMA, CSMA CD and CSMA CA. So in this video, we are going to learn in details about the random access protocols. The control access protocols are reservation, polling and token passing. The channelization protocols are FDMA, TDMA and CDMA. FDMA stands for frequency division multiple access. TDMA stands for time division multiple access and CDMA stands for code division multiple access. We are going to learn about this control access protocols and channelization protocols in the later videos. So what is random access? Random access means the stations do not need any permission to send the data or to access the link. The only condition which is there is whether the link is idle or not. If the link is idle, stations can transmit the data. And if the link is not idle, then it cannot transmit the data. On the other hand, there is no protocol that will define which station will send next. So these are the two parameters that define the random access. So conceptually, the random access means the two different points. One is the random access, second is the contention. For random access, as we have seen, no permission is required. If the line is idle, then the stations can transmit the data. And for contention, there is no protocol that will define which station will send next. Now there are certain questions that must be asked. When can the station access the medium? That must be defined in the protocol. What can the station do if the medium is busy? Number 3, how can the station determine the success or the failure of transmission? Number 4, what can the station do if there is an access conflict? or there is a collision. Let us understand the protocols one by one. We start with ALOHA. ALOHA stands for Additive Links Online Hawaii Area. This has been defined by the University of Hawaii. Now, ALOHA is a purely multiple access protocol without any mention of collision. We have pure ALOHA. Let's see what pure ALOHA is. Let's say we have 4 stations, station 1, 2, 3, 4, and they want to transmit data. Station 1 is transmitting frame 1.1. So this is the first frame of station 1 and this is the second frame of station 2. Station 2 transmits frame F2.1 and F2.2. Similarly for station 3 we have F3.1, F3.2 and station 4 F4.1 and 4.2. We can see here that when the station 1 is transmitting frame F1.1 there is no collision. But during this interval there is collision because at the same time station 2, 3, 4 all are transmitting. Again we have collision over here because here station 2 and 4 are transmitting. So for pure ALOHA there is a mention of collision because there can be collision and it cannot be prevented in pure ALOHA. Now vulnerable time of pure ALOHA is 2 times TFR. TFR is the time to transmit a frame. Let us look at slotted ALOHA. This is an improved version of ALOHA. Here the time slots are defined like S1, S2, S3, S4, S5, S6 and the stations can transmit only at the beginning of a time slot. So here you can see that at this instant of time station F3 is sending and station 4 is sending at a different instant like T1 and T2. But here stations can transmit only at the beginning of the time slot. So here and here they can transmit. So here we can see that if the station 4 here, if it wanted to send in a frame in slotted ALOHA, it cannot send at this instant of time, but it has to wait till the next time comes or the slot comes. Here also we can have collision, but the collision possibility is lessened as compared to pure ALOHA. The vulnerability time here is equal to TFR or the time to transmit a frame. Let us now concentrate on CSMA. CSMA stands for Carrier Sense Multiple Access. Here the property is sense before transmit or listen before talk concept. The channel is at first sensed and then transmitted if it is found idle. So let's say there are 4 stations A, B, C and D. Station A is transmitting at a time T1 and there is a certain propagation time TP. Station B senses at this particular instant of time. Station C senses it here and station D senses it here. So this is the propagation delay from A to D. So vulnerable time here is equal to the propagation time. So all these stations cannot send any data unless and until it senses the station, it senses the line to be idle. Now, in order to do this, there are various techniques. Number 1 is one persistent concept. The station continuously senses, and if it finds the line is busy, it will not send. It will send only if it finds the line is idle. So the flow diagram is like this. The channel is sensed. If it is idle, then the station can transmit. If it is busy, then again it has to go on sensing. Number 2 is non-persistent. In non-persistent, instead of continuous sensing, the station senses and waits for a particular instant of time if it finds the line is busy. Again, it senses and waits for an interval of time. Like this, when it finds that the line is idle, it can send the data. So this is the flow diagram. The channel is sensed. If it is idle, station can transmit. If it is busy, then it has to wait for a random amount of time, and then again it will sense the channel. Next is the P persistent or propagation persistent. The line is sensed, and when it is busy, it divides the time slot after sending into several time slots. And then when it is over, it can transmit. Let's look at the flow diagram. So here, at first, if the line is idle, the station sends with a particular probability outcome, and it looks into the channel whether it is busy or idle. Now it checks the probability outcome. If the probability outcome is less than equal to P, then the station can transmit, and if it is more than P, that is a probability, it has to wait a time slot. Then again it checks whether the channel is free or not. If the channel is busy, then it has to use a back-off process as the collision has occurred. So this is the P persistent. Let us turn our attention to CSMA CD, carrier sense multiple access collision detection. Here there are 4 stations again. Station A transmits the data at time t1, and the first bit of data takes certain amount of time to reach C. At this instant of time, C has not received any data from B, and it senses that the line is free, and then it starts sending its own bits. So the first bit of C is received by both the stations, that means A and B as well as D. Now, at this point of time, the first bit of A reaches C. So a collision is detected at C, and immediately C stops transmitting signals. So here, the difference is T3 minus T2 interval. So during this interval, C is sending the data. Now here, the C has also sent the data. So the first bit of C has reached A at this instant of time. So collision is detected at A because of C's data, and A stops. So A has transmitted during T4 minus T1 interval of time. Like this way, collision is detected, and then the transfer of messages is stopped. A CSMA CD network has a bandwidth of 10 Mbps. If the propagation time is 25.6 microsecond, you have to find out the minimum frame size. Let's look at the solution. TFR is given as 2 times propagation delay, or TP. Here TP is 25.6 microsecond. So TFR will be equal to 51.2 microsecond. The minimum frame size should be given as data rate into the time that we have obtained. So 10 Mbps into 51.2 microseconds. So 512 bits or 64 bytes. So this is the minimum frame size. Next, let us turn our attention to carrier sense multiple access collision avoidance. Here 3 terms are important. One is the interframe space, second one is the contention window, and the third one is the acknowledgement. With the help of this, collision is avoided. Now, initially the station continuously senses the channel, and if it is busy, it senses it. And at this instant of time, it finds the channel is idle. So immediately it does not try to send the frame. It waits for a particular instant of time given as interframe space. After the interframe space, it sees whether the channel is idle or not still, because at this interval of time, many other stations may be transmitting their frames. It now moves into the contention window. This contention window is divided into different time slots. And these time slots, the size of the time slots is in the form of binary exponential. Like initially, if it starts, there will be only a single time slot of random duration of time, after which the frame can be sent. And if it repeatedly finds that the channel is busy, then the time slots are added to this contention window and it waits for that amount of time. After that, it sends the frame. So, in order that there is no avoidance and it understands that the frame has reached the destination properly, the receiver must send an acknowledgement data, after which it will understand that the frame has reached the destination properly. And if it does not receive the acknowledgement and there is a timer set during which the acknowledgement must be received, if the timeout occurs, then it has to resend the frame again. This way, collision can be avoided. To summarize, in this video, we have learned about the taxonomy of multiple access protocols. We have looked into random access protocols like ALOHA, CSMA, CSMA CD, and CSMA CA. Thank you.